Hi, this is Miss Andrea. I'm here at the Children's Museum of Houston in Kidstropolis. I am in the Reliant Energy Station, and I am bringing you a project today sponsored by Reliant. So today I'm going to talk to you about electrical safety. And what made me think about this is this really cool toy called an energy ball. When you have a circuit, you have wires, you have an output, and you have an input. So your battery, you have wires, and then it makes it do something. So in the case of sound, when I connect them all together, I make a circuit and it does something. Oops. Makes sound, right? So the electricity is flowing through here. Electrons are flowing, electricity is flowing. With an energy ball, I have two little metal prongs here, and if I connect one side here and one side here, it goes off, right? The lights come on, the sound goes on. I've actually closed the circuit. So, is that electricity flowing through me? This is why I decided to do this project today, because it's not actually flowing through you. If it was flowing through you, you would get hurt. It would hurt. Because the electricity needed to do something like make the sound go has to be high enough that when it goes through your body, it would actually cause you damage. So the way that energy ball actually works is that it's kind of like a little bitty switch that doesn't take a lot of electricity, and that will close a switch that will allow the real wire to complete the circuit, and the actual electricity goes through that wire. So it's not actually going through, you're not like a wire for the energy ball. And the reason I'm telling you that is because I think sometimes when you see stuff like this, like really cool, you can connect a whole bunch of people, we could all touch fingers and we could make the ball light up. But then I started thinking, what if somebody thinks they can put their finger here and touch the things and make the light go off or the sound go off? And that would not be good. That's not what's actually happening here. When you have a closed circuit like that and the electricity is going through you, it has to be a large enough charge to go through your body. So your body's 70% water. That's why you're a good conductor of electricity, because water is a good conductor of electricity. So do not try to take a battery and a wire and connect to something else and yourself, because you're going to get a shock. It's not nice. Since I was talking about the energy ball, I decided to go ahead and talk about energy safety outside, because I think that there's a lot of things that we do that we're not aware of could be dangerous. One of them is you have electrical wires. So I made a little display today with some of my little birds on the wire. And the other thing is, why don't birds get electrocuted if they're sitting on electrical wires? Well, here's the reason why. You need a complete circuit. The electrons for electricity come from the ground. So they're always looking to complete the circuit and go back to the ground. The birds are not touching the ground. The birds are not touching the second wire. If they touch the second wire, then they would get electrocuted. So they don't have, their tails aren't long enough, or they can't spread out their wings far enough. These are far enough away to complete that circuit. So electricity is always going to find the easiest way, just like water from the top of a hill. If you let water go from the top of the hill, it's going to find the easiest route down. Same thing with electricity. So that's why the birds do not get electrocuted. Does that mean you could sit on the wires? I would not chance it, because chances are anytime that you are anywhere, gravity is pulling down toward the ground if you're touching the ground at all. So let's say that you're flying a kite. It's a nice windy day, that kite's flying, and it touches the wire. There is the possibility that that electricity can go through you and complete the circuit, because it's trying to go to the ground. And now you have given it a path toward the ground. So don't fly kites around electricity poles, electricity wires. Be very careful. It's the same thing with drones. You don't want your drone to touch the wire. You probably will not get electrocuted since you're not touching the wire of the drone, but you could cause an outage to all the people in your neighborhood. They would not be happy. And it's dangerous. It's dangerous to do that. So I wanted to also say that you're carrying your ladder, you're going to go help your dad, and that ladder touches the wires, you can also get electrocuted. So the important thing to remember is that anything touching this and also touching the ground is going to cause a problem. So don't fly kites, don't fly drones. Be careful when you're carrying things that are going up into the sky that might touch these wires. And believe it or not, be careful with climbing trees that are touching power lines. Even if they're not quite touching the power line, if you start climbing up this tree and then it touches the power line, it is possible that the electricity can go through the tree, because trees also have water and water is traveling through the trees. So I would just not chance it. Don't climb trees that are near power lines, and don't try to cut or don't let your parents cut around the trees that are touching power lines, because that electricity could actually travel through the lines and hurt you. A couple of more that are not outside is real simple ones, like I'm going to tell you about alternating current, AC, and DC, direct current. AC, DC, not the band, but the electricity, right? So DC is like this. When you have a battery and you plug it in and the electrons start flowing, they start flowing in one direction. That is direct current. Alternating current is what we have in our house, which means it can go back and forth. That's why it's called alternating. It's actually kind of a wave. And that is really dangerous, because if you touch just one side of this wire with the battery, it will not go off. You have to complete the circuit, because in order for the electrons to flow with your power plugs at home, where you plug in your outlets, if you touch either one of those, you stick something in those outlets, either one of them, because it's alternating current, you can get shocked. And the shock that you would get is, cartoons, it's kind of funny. Somebody gets shocked and their hair is all frizzy and their face is all full of soot. And in real life, it's not like that. In real life, you could get really hurt. So never ever stick anything in a light socket. Never. The other thing I'd like to tell you is, do not put electrical things near the bathtub. So maybe you're in the bathtub and you want to put your radio on, don't put it near your bathtub, because if it gets water on it, the electrical charge can actually go through the water and you can get also a nasty shock. So electrical stuff away from bathtubs. And the last thing I'm going to tell you about is one that I've heard from other students. They've told me that they sleep with their phone under their pillow. This is very, very dangerous. If you sleep with your phone under your pillow, it can overheat and it can actually catch fire. So don't sleep with your phone under your pillow. If you're falling asleep and you have the phone with you, put it away from you before you actually fall asleep. So I hope that this tips that I give you keep you safe. Please be very careful around power lines. It's very, very dangerous. If you're now a little bit afraid of the electricity, I don't think you have to be. We have a lot of safety things out there. Energy companies take very much care to make sure that people stay safe, but sometimes we're unaware, like when we're finding the light, we're not really thinking about the electricity, right? So I just want to bring those things up to you because I would like you to stay safe. This is Miss Andrea, signing out.